This extreme value exists and grad of g is not equal to 0 on the surface on the surface g of xyz is equal to k. It is given here, constant is given here, bit a. Find all value of xyz and lambda. How you solve this problem here? This procedure it is. And lambda such that grad of function of x, y, z is equal to lambda into grad of g, that is x, y, z. We write down like this. Lambda is our Lagrange multiplier, we say here. Grad of function of x, y, z is equal to lambda into grad of g, x, y, z. Grad of g it is given here. Then, and the constant it is your g of x, y, z is equal to k. Constant is subject to the constant, this is given here. So we have to write down like this. Then bit b. Evaluate f f at all points that is x, y, z. The result from step A step A, evaluate f at all the point x, y, z. Get result from step A. We'll get from the step A, we get that result. Okay. The largest of these value, then after that, largest of these values is the maximum value of f. Maximum value of f and the smallest of these value is the minimum value of f. Okay. If we write down the vector equation grad of f, it is a vector equation lambda grad of g. Grad of f lambda grad of g x, y, z in terms of components, in terms of component, then the equation in step A become that is your grad of f. So it is by comparing this, it is your del f by del x, that is your fx is equal to lambda gx, fy is equal to lambda gy, fz is equal to lambda gz. It is clear? It is clear. And where the constant it is given as g of x, y, z is equal to k. So it is one equation, two equation, three equation, and it is four equation. We have four equation, four unknown. By using this, we have to solve, find out the value of x, y, z, and lambda. Okay, four equation and four unknown. If we solve, we can find out the value of x, y, z, and lambda. Or the function of two variables, it is same. It is if it is f is the function of x, y, and g is the function of x, y is equal to k, then we can write down it is fx is equal to lambda gx and fy is equal to lambda gy, where g of xy is equal to constant k. That is constant below. Okay. So here, example. The same example I had already done in the last article. Rectangular box without lid I am doing by using the Lagrange multiplier method. Same example. Can I omit? Example. If I solve the example, then it is easy for you how to solve by using the Lagrange multiplier. Example is your a rectangular box. All of you have that question. A rectangular box without a lid is to be made from 12 meters square of cardboard. Last article I had done this problem. All of you have written that question. Same question I'll do now by using the Lagrange multiplier. Last article. You have the, can I write down again that question? A rectangular box without lid, without a lid, is to be made by 12 meters square of cardboard. Find the maximum volume of such a box. So what is the length, breadth, and height of the rectangular box? I am not doing the figure. Tell me. Length, breadth, and height.
X, Y, Z.
Yes. We want to find out the maximize the volume of the box. That is your, where I am writing, volume V is equal to X, Y, Z. Okay. So now here, constant what is given? G of X, Y, Z is equal to twice of YZ plus twice of XZ plus XY is equal to 12. Isn't that it? It is given or not?
Yes, ma'am.
So now here it is G of XYZ is equal to this and V of XYZ. So I can write down it is your grad of V, or grad of, if you say it is a function of XYZ, then grad of f of XYZ is equal to lambda into grad of G. That is, by comparing the component, what we get? We get that del f by del x is equal to lambda into del G by del x. Is not it? So we can write down here it is fx is equal to lambda into gx. Okay, that is equation. Fy is equal to lambda into gy. Fz is equal to lambda into gz. Here the constant is given to you, this one. So say this is. So how many equations we have now? How many equations?
Four equation.
4 equations. How many unknown?
3.
X, Y, Z and lambda is there.
Oh, yes, ma'am.
4? Okay. So what will get here? It is, will get del f by del x is equal to yz is equal to, I am writing here. Now, yz is equal to del f by del g. Sorry, del g by del x. Del g by del x is your z plus y, 2z plus y into lambda. So it is your lambda into del z by del x, lambda into, that is your 2z plus y. So it is your equation 1. I don't write here. So it is equation 1. Okay. Similarly, del f by del y, xz is equal to lambda into del g by del y. Del g by del y is equal your 2z plus x. Okay. Then fz, del f, so it is xy is equal to lambda into del g by del z. So it is 2 into x plus y. Okay, 2x plus 2y. And the constant it is given as twice of xz plus twice of yz plus xy is equal to 12. So this is 3, this is 4. Now we solve and find out that there is no general rule for solving system of equation. System of equation. Okay. Now we multiply x in 1, y in 2, and z in 3. we have x, y, z is equal to x lambda 2z plus y, then x, y, z is equal to, that is your y here, y lambda 2z plus x, then x, y, z is equal to, that is your uh, z lambda 2 into 2x plus 2y. Okay, so set is 0, 5, 6, 7. 4 over equation 5, equation 6, 7. Here lambda is not equal to 0. You see, if lambda is equal to 0, then all volume it becomes 0. You see. Is that it? It is clear up to this? Up to this it is clear?
Yes, ma'am.
Okay. So now here, from 1, 2, 3. From 1, 2, 3. Sorry, my first number 5, 6. 1, 2, 3 to which one? 1, 2, 3. If I am writing it is lambda is equal to 0. If lambda is not equal to 0, then volume becomes 0. This is become 0. If lambda becomes 0, then 2 up by this value is also become 0. Now I'm going to okay. Now from 5 and 6 equation. From 5 and 6 equation, from equation and 6 and 5, we have x lambda 2z plus y, x lambda, so it is your lambda into 2zx plus xy is equal to lambda into 2zy plus xy. Okay, so lambda lambda cancel out, value xy cancel out. So what you get? What you get here? Xz is equal to, this implies x is equal to y if z is not equal to 0. Here, if z is equal to 0, then your volume becomes 0. Okay. It is okay or not? All of you clear here or not? I'm asking you.
Yes, ma'am.
Now from table 5, 6, 6, 7. Find out. You find out what you are getting. Two yz plus xy is equal to 2xz plus 2yz. Is not it? 2xz. So 2yz, it is cancel out. Taking, if x is not equal to 0, then y is equal to
2z.
2z. Okay, if x is equal to 0, then volume become 0. Okay, so what we get here, it is x is equal to y is equal to 2z. We get, put this value in the equation 4, that is our constant given. Put this value in the equation 4. Equation 4 is our constant, that is your 4 kitela 2yz plus 2xz plus xy is equal to 12. So I am putting the value x is equal to y is equal to 2z. So what you get, 2z, it is your 4z square. This implies 4z square plus it is x is equal to 2z, it is also 4z square. Then it is 2z, 2z, so it is also 4z square is equal to 2. So what is the value of z? What is the value of z? Tell me.
Plus minus 1.
Yes, it is plus minus 1. What do you consider?
1.
Yes, because it is the volume. It cannot be negative, so it is z is equal to 1. What is the value of x? Z is equal to 1. X is equal to 2z, na? 2. Y is equal to also 2. So volume V is equal to 2 into 2 into 1. That is our 4. Clear? That is the maximum value. If the question it is given to you, so you are getting your multiple choice. Now, otherwise, question may be given to you by using the Lagrange multiplier. You have to solve by this way. If the question it is given by using the Lagrange multiplier, you have to solve by this way. Otherwise, you are getting a multiple choice, you can use any method. Next example. I'm going to omit. All of you have written? All of you have written?
Yes, ma'am.
Yes, ma'am.
Find the extreme value of the function of x, y is equal to on the circle x square plus y square is equal to 1. Extreme value of this function of this is on this circles x square plus y square is equal to 1. So the constant it is given, that is your g of xy is, it is having the two variables here, this question. So mandate you may get the question of two variables, simple one. So okay. Now here constant it is given and your functional will find the extreme value, means it is either maximum or minimum. So here it is given and constant subject to the constant it is given as g of x square plus y square is equal to 1. Okay. So now here f of x is equal to lambda of gx, f of y is equal to lambda of gy. It is function of two variables. So what you write down? F of x is your 2x. 2x is equal to lambda of gx. It is your lambda 2x. So it is this implies f of y it is 4y is equal to lambda of gy, that is lambda of 2y. Okay. So here it is 1, it is 2, and subject to the constant, it is given as x square plus y square is equal to 1. We have 3 questions and 3 unknown. So my aim is to find out the value of x, y, and lambda. The equation 1, 2x is equal to equation 1, 2x is equal to lambda into, so what is the value of x? Equation 1. Is not it? You see, this implies this value. Clear? It is clear? I'm asking you, it is clear? Equation 1. I'm audible? I'm audible?
Yes, ma'am.
It is clear?
Yes, ma'am.
So if you put the value x is equal to 0 in equation 3, so what is the value of y? Y is equal to equation 3. X is equal to 0. Y is equal to
1.
1 plus minus 1, not only 1. Y square is equal to 1. Y is equal to plus minus 1. Okay. So from the equation 2, equation 2, what you get? Take this side. 4y minus 2y lambda okay. If lambda is equal to 1 here, we are getting the lambda is equal to 1 here, then And what is the value of y? Lambda 1 I put here. The value of y is equal to? Array, here I'll put that the lambda is equal to 1 I got here, from here. So value of y is equal to 0. Lambda 1 hele, take common y, then it is, will get it is 0. Value of y is equal to 0. Clear? It is clear or not? I am asking you. It is clear. Tell me it is clear or not? No response from your side. I am audible? I am audible?
Yes, ma'am.
So I got the value of lambda 1 from equation 1. I'll put that value in equation 2, lambda is equal to 1. What about the value of y? Y is equal to 0 or not? Yes or no? Yes or no? I'm asking you.
Yes, ma'am.
So when y is equal to 0 in equation 3, what about the value of x? What about the value of x? X रे value कितना होगा? Y is equal to 0 in equation 3. This is 0. The value of x is equal to plus minus 1. So what is your critical points here? The possible extreme values point are. When x is equal to 0, y is equal to plus minus 1. So it is 0, 1 and 0, minus 1. When y is equal to 0, x is equal to plus 1. Okay, these are the extreme values. So now we have to evaluate at this extreme value what is the functionality. So therefore, we now evaluate f at these 4 points. F of f of 0, 1 is equal to how much here it is? F of 0, 1 is equal to, tell me, f of 0, 1 is equal to 2. Yes. First 0, 1 थी ना, point उड़ा कौन थी? F of 0 minus 1 is equal to?
Again 2.
Okay. F of 1, 0 is equal to?
1.
F of minus 1, 0 is equal to?
1.
1. So maximum value at which point? Therefore, the
0
maximum,
plus minus 1.
yes, maximum value at the point 0 plus minus 1. And the value is f of 0 plus minus 1 is equal to 2. Is not it? And the minimum value? F of that is plus minus 1, 0. That is value is your 1. At this point minimum value, at this point maximum value, and the functional value is maximum value is 2 and the minimum value is 1. Clear? Any doubt? Any doubt you have? Any doubt you have? I'm asking you, any doubt you have here?
No, ma'am.
Now come to your classwork problem and your assignment problem. Here, assignment problem. Your classwork problem is example 1, I think I had already done, and exercise 3. Classwork problem. Example 1 and your exercise 3. And assignment is your question number 6. Assignment is your question number 6 only. Now I think example 1 are already done. Okay. Example 2, example 1. Yes, it is over. Example 1 is over. Now, question number 3. Can I omit? I'm going to omit.
Yes, ma'am.
Use Lagrange multipliers to find the maximum and minimum values of the function to find the maximum minimum of the function, that is function of x, y is equal to x square subject to the constraint subject to the constant xy is equal to 1. Sorry. Okay. Try to do yourself. Try to do yourself, then I'll do. Hmm. Hmm. Can anybody solve what is the value of lambda and what is the value of x and y?
Lambda is 2.
Hmm? Yes, lambda is equal to 2. By solving 1 and 2, one equation 2 into x plus y, it is your lambda into x plus y, so it is lambda is equal to 2. If lambda is equal to 2, then the value of x is equal to this implies x is equal to y. Is not it? Lambda is equal to 2, equation 1 became x is equal to y or not?
Yes.
So x is equal to y, you put in your equation 3. So what do you get? Y square is equal to 1, y is equal to plus minus 1. Is not it? So x is equal to maximum value. Whatever you want to take. If you take the point, it is your 1, 1, minus 1, minus 1, minus 1, 1. Combination, it is your minus 1, 1, 1, minus 1. Then it is your minus 1, minus 1, or minus 1, 1, 1, minus 1. Okay. So what will we get? Because it is square here. So it is the maximum value of the function. There is no minimum value here. Sorry. It is plus minus 1, plus minus 1, 2. It is your minimum value. Minimum value of the function, not maximum. Because the function is not bounded. Function is not bounded. Not bounded, that is your limit x, y tends to, that is infinity 0, function of x, y is equal to limit x, y tends to infinity 0, x square plus y square is equal to infinity. Yes, that's why here only the minimum value, that is 2. Extreme value, the question is given. We have only find out the minimum value and there is no maximum value because it is not bounded. Write down this point. So you may get question here. Lagrange multiplier, you may have this type of question. It's very simple one. Find out the extreme minimum value of this function, or find out the maximum value. The option may be given. So you may write down it is no maximum value. Clear? It is clear?
Yes.
So this article is over and chapter 14 is over. What is the question number 6? Do it yourself. Question number 6. Function of x, y is equal to. I am writing the question now. Do it. Question number 6. That is your assignment. Question. Function of xy is equal to e to the power xy. Where subject to the constant it is given as x cube plus y cube is equal to 16. Lagrange multiplier to find the maximum and minimum value of the constant subject to the given constant. Do it. Do it. Try to do. Hmm. You are able to do? Any doubt this article? What you will do here? Hmm?
F of x equals to lambda into
Yeah, no. It is your 8 grad up, or you can write down it is your 3 question, 3 unknown. Do it yourself.